Now that we've talked about atoms and molecules and bonding, we're going to be talking about chemical reactions and the law of conservation of mass. So a chemical reaction is a process that rearranges the chemical bonds to create new substances. And so, for example, if we're talking about creating water, so we have an atom, we have a molecule of H2, so a molecule of hydrogen. We have a molecule of oxygen, which is O2. We have another molecule of hydrogen, which is H2. So the covalent bonds between each of these molecules needs to be broken, and then they'll reform. New covalent bonds will form between the hydrogen and the oxygen to create H2O. So we end up with 2 molecules of water. There are 2 parts to chemical reactions. We have the reactants, okay, and the products. The reactants are the substances that are combined and changed during the chemical reactions. So the reactants are the things that we start with. They're going to react with each other to create the product. So the product are the new substances that are created from the chemical reaction. So when you're looking at a chemical equation, you'll see an arrow in the middle. Whichever way the arrow is pointing, it's pointing toward the products. So whatever's on this side of the arrow, okay, away from the pointy part, are your reactants. And then what the arrow is pointing to, it's pointing to your products. And the way that we read this arrow is the word yield. We say yields. So H2 plus O2 plus H2 yields 2 molecules of H2O. Another thing that we need to talk about are open versus closed systems. An open system is a situation in which matter can either enter into a chemical reaction or is lost from the chemical equation. Okay? So an example of that is when we were doing the baggy chemistry, and if we had a bag that was open, that was an open system. A closed system is a situation in which matter is contained within the container in which the chemical reaction occurs. So when we were doing the baggy chemistry and we did the baking soda and vinegar reaction, initially we had the bag closed, and you saw the bag puff up with the gas. And the reason that it did that is because gas was being created, carbon dioxide was being created. It couldn't leave that bag because the bag was sealed shut. And then as it got fuller, I asked you to open the bag so that it didn't pop the bag, so that carbon dioxide was able to escape from the bag, creating an open system. So air was able to get in, the carbon dioxide was able to get out. So how do you know when you're looking at a chemical equation if it's an open or closed system? Well, if the atoms in the products are the same as the atoms in the reactants, it is a closed system. If the atoms, and they have to be the same numbers of atoms. If the atoms in the products are different or are in different amounts between the reactants and the products, then it's an open system. So if we're looking at this, let's count and see. So let's look at hydrogen. How many atoms of hydrogen do we have in the reactants? We have 1, 2, 3, 4. Okay? How many atoms of oxygen do we have? 1, 2. So let's look at our products. So over here we have 4 hydrogen and 2 oxygen in our reactants. So let's look at our products. 1, 2, 3, 4 hydrogen, 1, 2 oxygen. 4 hydrogen, 2 oxygen. So we know that this is a closed system. So let's talk about the law of conservation of mass. The law of conservation of mass states that matter is neither created nor destroyed in a chemical reaction. So what that means, okay, in plain terms, is that all of the atoms that are present at the start of a chemical reaction are present at the end of the chemical reaction. So the total mass of the reactants must equal the total mass of the products. Okay, so when we're doing out a chemical equation, we'll assume that it's a closed system because we'll balance it that way, so we'll see that they're the same. So even in an open system, just because maybe those atoms are being lost, because things can come in and out, doesn't mean that they're not there or that they stop existing. They're still there, we just might not be able to calculate them because in an open system they're being lost and other things are coming in. So what are chemical equations? A chemical equation is a short, easy way to show a chemical reaction using symbols instead of words to summarize a reaction. So rather than writing out hydrogen plus oxygen plus oxygen, we can quickly write it in an easier way to make it simpler to read. So if we're looking here in a chemical equation, right, we have our reactants here, we have our products over here. Remember, we have that arrow that we read as the word yields. So what we have here, we see this large 2 in front of both the hydrogen atoms, molecules in the reactants and in front of the entire product here. Those are called coefficients. A coefficient is a number placed in front of a chemical formula in an equation. What that tells us is how many atoms or molecules of a reactant or a product take part in the reaction. So you don't need to write a coefficient of 1. It's just assumed. So if we're looking here, right, we have copper, which is Cu, and oxygen, which is O. So here on this side we have 1 copper and 2 oxygen. But over here we have 2 copper atoms and 2 oxygen atoms. So this is not balanced. So we would use a coefficient to balance an equation. So we would put 2 Cu plus O2, okay, on this side. So we would add a coefficient of 2 in front of our copper to show that we have more than 1, so we can balance the equation. So let's show you right here, this is not a balanced equation, okay, so we have H2 plus O2 yields H2O. So let's look. So we have 2 hydrogen atoms plus 2 oxygen atoms. Okay, so this is showing them broken up. Okay, HOO. Okay, so now it's showing those same atoms with the bonds broken. Okay, but if we look over here, we have yields, right? We have H2O. We've got 2 hydrogen, but we've only got 1 oxygen. Okay, that doesn't work because here we have 2 oxygen. So we would need to put a coefficient of 2 right here to show that we have a coefficient of 2 here to show that we have 2, and then we would need to add a coefficient here so that we could have 4 hydrogens plus 2 oxygens. If we put the coefficient of 2 here, right, we multiply 2 times the subscript of 2 gives us 4, 2 times 1, because we're assuming that there's a 1 here, gives us 2. So we use the coefficient to balance the equation. So we never change the subscripts, we only change coefficients. Okay? So when we're looking at a chemical equation, we've got our coefficient, we multiply it by our subscript to equal the total number of atoms of each element. So let's look at the steps to balancing chemical equations. Our first step is to write the equation. So H2 plus O2 yields H2O. So now we need to count the number of atoms. So we counted, right? We've got 2 hydrogen here, plus 2 oxygen here. Now if we count the products, we've got 2 hydrogen, so it looks like we're okay. Oh, but we've only got 1 oxygen. So that's a problem because we've got 2 here and 1 here. Now we're going to use coefficients to balance the atoms. So if we first add our 2 here, so that we can make this be 2 oxygen, so we can make those equal, right? But then we have a problem because we've taken this 2, we have to multiply it here, that gives us 4. So now we've got 4 and 2, but 2 hydrogen here. So we have to add another coefficient here to get 4. Okay? Now we're going to look back and check. So now we end up with 2 times 2 is 4 hydrogen plus 2 oxygen. We're going to look over here. 2 times 2 gives us 4 hydrogen. 2 times 1 gives us 2 oxygen. Okay? So now this is balanced. So again, never change the subscript. Always change the coefficient if you need to. Okay, now what you need to do is go to Edmodo and complete the Edmodo quiz.